Well, thank you everyone for joining today. We're really excited to have you with us for our session on getting hands-on with multimodal machine learning. My name is Michael Ortega. I'll be your host. We're going to cover a really cool use case on how to predict customer review ratings using a declarative approach. We'll talk about those approaches. We'll talk about multimodal machine learning a bit. With that, let's get into it. My name is Michael, as I mentioned. I'm the head of marketing here at Predibase. Been in the ML industry for about a decade now. And I'm joined by Abe Malik, who's a product management leader over at Predibase as well. For those of you who haven't heard about Predibase, simply put, we're on a mission to make state-of-the-art machine learning easy, accessible, and impactful for every organization out there and every level data user. Our founders have good pedigree. They come from some leading commercial organizations, Uber, Googles of the world, who are doing really cool AI projects, also academia, and also the founders of two really popular open source projects, Ludwig, which is a declarative deep learning framework, as well as Horvath, which is great for training deep learning models at scale. And Predibase itself, as a platform, we're the first platform to take a low-code declarative machine learning approach and offer that to organizations, making it easy to rapidly build, iterate, and train and deploy models for every level user out there, whether you're an analyst all the way to an expert data scientist. And we'll talk a little bit about that today as we cover multimodal machine learning. A few brief webinar logistics. As a reminder, all lines are muted, but that doesn't mean we don't want you to ask questions. So we have a chat panel on the side of the screen there, sort of where the surveys are pulling. You can add your questions. We have someone moderating, but we'll also do a live Q&A at the end. So if you have questions about how we built the model, questions about the platform or declarative machine learning approaches, anything, we're here to answer those. Today's session will be recorded and made available afterwards. For those of you who are interested in learning more about Predibase, you can always go to our website and request a demo. And of course, Ludwig is a thriving community, and we welcome all people to join it, download the open source package, try it out, and always looking for more contributors. We have a pretty good audience already, but love for you to be a part of the community. So today we're talking about multimodal machine learning. And what does that mean? Well, I think everyone knows it's using different data modalities, right, to build your predictive models. And what we find, and I think many people can attest to this, is that most teams are building their models with usually just one type of data, structured tabular data. But the reality is that most data that exists out there at the enterprise is unstructured, 80 to 90%, and it's growing at a rapid clip. And it's everything from, if you're a financial institution, think about text documents like that you exchange with your customers, or it could be customer service chats. It could be customer reviews if you're a retailer. Imaging, very popular in the medical industry, right? You have pathology scans and X-rays, but also in industries like manufacturing, where you have imagery of sort of the factory floor, and all the way to things like video. If you're in media and entertainment industry, obviously lots of video being produced every day. So the short of it is there's tons of data that's unstructured, and as we all know, within this data, there's buried lots of signal that can be used to develop better predictive models. But the reality is that while all of this data, or most of the data that we have at our fingertips or that we're producing is unstructured, less than 20% of organizations are actually using that data within their models. So if they're building models, they're, again, usually tabular, or probably not multimodal, and not taking advantage of all the great insights that are trapped in there. And I want to spend a minute to talk about, why is that happening? Okay, what's going on? And I think in order to do that, let's take a broader view of sort of ML and AI in general. And what I think everyone can speak to this. We've heard the stats: 60 to 80% of models never make it into production. If they do, it takes 6 to 8 months and usually longer. And there's this interesting study, and what the survey showed is that you looked at companies that are building ML sort of applications. Only 10% are really seeing at that top tier really strong return on those projects. And then there's the 90%, the everybody else. So there's sort of this dichotomy of haves and have-nots. And the companies you would expect who are really seeing great results are those FANG sort of tech forward, born in the cloud companies like the Ubers and Apples of the world, who have the most robust data science teams, the best engineers from Silicon Valley and around the country and around the world, and hundreds of people at their disposal who can use these different open source packages, can build infrastructure and build these projects. But most organizations are still struggling. And so I want to dig in a little bit deeper on one of those 10%. This is actually a smiling guy on the bottom here is Piero Molino, who's the founder of Predibase and the creator of Ludwig, which we'll talk about later. He's the founder of a company, but he was also the founder at Uber of one of the founders of their AI lab. And while he was there, he worked on many different ML projects that were sort of mission critical, everything from using NLP to understand, customer sort of support issues and classify that into information that was easy for them to respond to, whether it's a support team, or automate the response to things like fraud detection or recommender systems for things like restaurants and Uber Eats. So we worked on a lot of these projects. And this is a sort of a view into like what his world looked like. Uber had a lot of different tools and solutions they kind of pulled together to build these models and infrastructure they manage. And and Piero himself is an expert. He spent his career in programming and ML and is really adept to use different frameworks and tools that are out there. And so he would tackle a project like this intent classification one. That's the customer support one we mentioned before. And that first project, business would come to him, he'd meet with them to find the project. And then he'd go figure out what's the best sort of framework to use. In this case, it was TensorFlow. He'd go write a bunch of code, low-level code, and pull in new features, iterate on it until he got the perfect model. And that's a lengthy process, right? It took him 1,500 lines of code, and he's an expert. It could take 5 months. And then, of course, getting that into a production environment where the code is needs to be supported, and you oftentimes have these brittle pipelines. Getting it translated into a production serving environment and infrastructure is challenging, and that would take another 7 months. So, one project could take easily a year, and this was sort of his life. He would take one project, tackle it, would take a year, move on to the next project, in this case, 9 months, using PyTorch, another 900 lines of code, and so on. And while, as an expert user and an expert data scientist, Piero can really tackle a lot of different problems and build these real powerful solutions, it's not the most efficient way to do it. And so what we've seen in recent years, and many may have worked with some of these tools, is the kind of the growth and adoption of AutoML applications like the data robots of the world that really sought to sort of fix this problem by automating the entire ML sort of workflow, or at least the ML sort of building process. And these tools largely take kind of a brute force approach where you define your features and your data you want to use, and then they just test and run a bunch of models against it, train a bunch of models, and give you an output. But as we all know, the data science journey is highly iterative. Your first model is never your last model. You want to continue to iterate, swap in new features, swap features out, tune some parameters, maybe test a new encoder. And what these tools lack is the ability to really do that. It's often described as, you might have heard, the black box problem, where AutoML tool sort of gives you a result, and you can't really edit that model the same way that like Piero would go in and finally tune his models. And there's this great paper you can read out there called Wither AutoML, and this is where this quote comes from, where they interviewed a number of different data science teams and really dug into sort of the pros and cons of AutoML. And the TLDR was, these tools are great for doing some rapid experimentation, but when it came to actually like wanting to get to the ideal and optimal result and get that model into production, the tools quickly broke down because they lacked the flexibility that teams really needed, especially expert users. And so this is sort of the world we live in today. If you look at these two circles, really, we have this, this sort of DIY approach on the left, where organizations are using a patchwork of frameworks and open source tools, sort of your 10%ers of the world, and managing all of that in the infrastructure, which is really challenging. You need expert users, as we know, is very powerful and flexible, but takes a long time to get a model into production. And on the right side, you have this AutoML sort of applications that, while they're simple and automate a lot of that workflow, they're not flexible, and they don't allow the teams to really take their models to the next level. And really, when what we see is actually a third option. This is a false dichotomy, and something we'll talk about a little bit today. And there's a new set of solutions and tooling that sort of marries the best of both these worlds that are called declarative systems, where they take a low-code abstraction layer on top of the machine learning workflow that allows you to rapidly build and automate some of that process into training and developing and deploying models, but give you the flexibility to finally tune your models at an abstraction layer. And Abe is going to show you kind of what those systems look like a little bit later in more detail. But most organizations don't know that this third option exists today. So let's go back to our 10% for a minute. Why are these companies successful? Well, I mentioned before, they have some of the best engineering teams out there, but they know something that most of us don't. They know about these declarative systems. And in fact, Apple, Meta, and Uber have all developed declarative tools and use them at scale to help their teams build models faster, deploy them faster. And now the thing is, all these tools, with the exception of Ludwig, which came out of Uber, are proprietary. They're internal only, so you can't access them. They're really only for their own organizations. Now, Ludwig, which started Uber, was actually created by Piero. And what Piro would tell you is he created it because he was lazy and didn't want to write more code. But that's actually not true at all. The reason he created Ludwig was two things. One, he knew the process was inefficient and he wanted to move faster building some of these complex, especially multimodal models. And then he wanted to democratize ML in his organization by making it easier to use this abstraction layer that you get with a declarative approach. And Predibase as a company is the only enterprise organization that's bringing this new approach to enterprises out there. Because as we know, open source tools like Ludwig are wonderful. They allow you to do a lot of things and experiment, but managing infrastructure, building capabilities around that to really address the entire ML workflow takes a lot more. And so Predibase is really focused on making that accessible, this sort of approach to more organizations. So it's a bit of a preamble about why, obviously a lot of unstructured data out there, why organizations are struggling with ML at large and sort of the opportunity for multimodal data. But what I'm going to do now is pass it over to Abe. He's going to go a bit deeper into sort of how declarative frameworks work, why they're critical for multimodal workflows, and then he's going to show you how to get hands-on using Ludwig and Predabase to address a really cool multimodal use case, which is predicting customer reviews, which has lots of applications across many different industries. So I will stop sharing and hand it over to Abe now.
Awesome. Thanks, Michael, for that introduction. Let me go ahead and share my screen. Cool. So today I'm really excited to show you an interesting multimodal use case around e-commerce review predictions. My hope is that this can serve as an interesting use case, but also help showcase the power of Predibase and declarative machine learning systems overall. And so before we dive into the use case, I did want to just set the stage and give some background into Ludwig and Predibase and sort of what we're offering in the market. Cool. So Ludwig is an open source modeling framework that, as Michael mentioned, our founder Piero created at Uber. And there are a few key principles of Ludwig. The first is that it's very easy to get started. And so you don't need to have any machine learning expertise to go ahead and understand that for a given data set, what are the input features that you're trying to predict, that you're trying to use for prediction, and what is the output feature that you actually want to predict? What does that target or output variable really look like? And so Ludwig allows you to basically, just using these input and output features, go ahead and get an end-to-end ML pipeline without understanding or even having to know any of the underlying machine learning logic. At the same time, it also provides an expert level of control, so that if you are maybe more experienced with data science and you want to, let's say, modify your encoder or go ahead and add things like dropout or L2 regularization to fix overfitting, these are also possible and right at your fingertips. There are also some really advanced functionalities. So let's say you want to train or use hyperparameter optimization across a distributed set of machines, you can go ahead and do that as well. And so the key principle here is that Ludwig is really targeted for all types of users, regardless of your machine learning expertise. And this adoption has been shown in the community. Since it was released, Ludwig has received over 8,000 stars on GitHub and routinely sees over 3,000 downloads a month, with over 100 active contributors and around 85 commits a month. And so in the community, we've seen all types of users, from experienced data scientists to data analysts to even software engineers that are really looking for a fast way to go ahead and get started with machine learning in their organization. So now let's take a look and peel back the onion a little bit and see how Ludwig works under the hood. One of the core ideas of Ludwig is this idea of an ECD architecture. And so what that stands for is encoder, combiner, decoder. And while this may look a little intimidating at first, I think the high-level idea here is that machine learning is really just a function, right? And it's a function that takes your input data, no matter what that format is. Maybe you have some text features, maybe you have some category, numerical, some more structured features. And it maps that to whatever output you're trying to predict. So maybe you're trying to predict some text, or maybe you're just trying to predict a simple category or numerical value. The idea here is that Ludwig is a nice abstraction layer that sort of takes this meta-level view and allows you to say, okay, how can I mix and match the different types of inputs and outputs that I want to create, and do that all through this one, what we like to call compositional model architecture. And so some of our open source users liken this to Lego blocks for machine learning, because you can really take any data set you want and sort of map it to this architecture. And so to give you an idea of like what this actually looks like in practice, let's go through a few examples. So let's say I wanted to do or train a text classifier. The way I do that is actually just say, okay, well, I have some text as input, and what I want to predict is some category, right? How can I slot or categorize these different text inputs into a series of category outputs on the other side, right? And so here you can see that in this case, you just have one input, that's your unstructured text, and you're mapping it to your one category feature on the right. At the same time, you can also go ahead and do an image captioning use case as well. So in this case, you'd have an image as your input feature and text as your output feature. And again, the use cases can just kind of can go on and on. You can use multiple input features. So you can say, hey, maybe I want to build a visual question answering system where I have an image as well as like a text question, and then I want to go ahead and predict like a yes or no answer to that question, right? In that case, I'd have image and text as inputs, and I'd go ahead and have binary as outputs, right? And so the flexibility of this really can't be underscored enough. And so today we'll actually look at a slight extension of this, but this is probably like a use case you're all familiar with, right? Which is regression. In this case, we're trying to predict a numerical output on the right. But rather than just kind of solve a classic regression problem, we'll see that we'll actually introduce not only structured data, such as your category, numerical, and binary features, but we'll also go ahead and include unstructured data, like your text from the reviews that we'll see. And so we'll actually be able to use both your structured and unstructured data to go ahead and use this Ludwig ECD architecture and train the model. Cool. So with this in mind, we've built Predibase as sort of a managed Ludwig platform. And so what that means is that it's the first low-code declarative ML platform with Ludwig at its core, designed to help you go from data to deployment, allowing you to build models faster, iterate with complete control and flexibility, and then ultimately go ahead and deploy those models to see real business value. So what does that look like in practice? Well, we see that Predibase offers, in our opinion, the fastest way to go from data to deployment. And so what does that mean? It's been purpose-built to serve different types of users. So whether you're a data scientist, analyst, software engineer, no matter what your expertise with machine learning is, chances are you'll find value within the platform. The second is really around having an intuitive model building experience based off of Ludwig, which is able to handle multiple modalities and ML tasks with ease, as we just saw in the previous slides. And then finally is this idea of a unified next generation AI platform. If I was to look at the market today, I think there's on one side, there's novel point solutions that solve a very specific problem, let's say model monitoring. And on the other side, there's, let's sort of say like existing legacy auto ML platforms that just don't quite get the job done to go ahead and put models in production. And so in my mind, this leaves a nice opportunity for a next-gen AI platform like Predibase to go ahead and say, hey, how can we really solve this end-to-end journey using a modern tech stack and allowing you to kind of build for scale. Cool. So as I was mentioning, there are multiple interfaces for all levels of users. As you can see here, there's this idea that we've created called PQL, which stands for Predictive Query Language. And what this essentially allows you to do is bring machine learning very close to the data. And so PQL is nothing but a slight extension of SQL with some additional built-in predicates around predicting and machine learning. On the other hand, we do offer a graphical user interface, which I'll spend a lot of time today showing in the demo, as well as a Python SDK for more technical data science type users. Awesome. So now let's turn to a little bit about the use case and multimodal data. And so I think, well, let's start by kind of talking about, as Michael alluded to, the power of structured and unstructured data today. And so as we look across the industry, we see a variety of high-value multimodal deep learning use cases. So in healthcare, for example, we've seen use cases around disease prediction, where organizations want to use patient history, medical images, even text reports to go ahead and understand what is the risk of a patient and how likely are they to have a specific disease. Again, this is all being proactive. So before they've actually been kind of diagnosed with a specific disease. How can we use machine learning to understand and find the signal and what those risk factors are? The use cases kind of expand across industries. So maybe in financial services, there are things around risk analysis. In retail, you can imagine there are examples with recommender systems where you want to use like a product catalog, understand the images, as well as some descriptions of the features to go ahead and personalize those recommendations for users. And then in manufacturing, again, being proactive and understanding how can we do predictive maintenance using both sensor data, image data, and really any sorts of structured and unstructured data you have to kind of understand the risk of breakdown of any equipment. And so today I'm really excited to show you this example multimodal use case around e-commerce review predictions. And specifically, we'll be looking at how can we predict customer ratings so that this organization can implement proactive product changes. And so to set some context, let's imagine we're an online retailer and we're launching a new product, and we'd like to proactively understand how well the ratings will be of this new product. And we can assume we've kind of gathered some initial data and some feedback that we're going to use to go ahead and train the model. And so with this information, we can then go ahead and identify what are some of those key drivers for those negative ratings and start to improve the products before we go ahead and do that widespread launch. And so while in this case, we're interested in predicting the actual numerical rating, this use case can be extended pretty easily, and I'll show you in the demo, to a product sentiment or text classification use case, depending on what you're trying to predict. And the last thing I kind of want to call out here is just the amount of rich data we have in this use case. And so we have both our structured data, so things like the age of the reviewer and some customer demographic information, as well as purchase histories. But we also have very unstructured data in the form of text, where we have our review titles and review descriptions that we can use machine learning on to really understand the context of the reviews and what users are really saying in their case. Cool. So before we dive in the demo, I just want to kind of emphasize and highlight what's the sort of typical experience today. If you were to go ahead and say, hey, I want to build this e-commerce review prediction use case, how would I go about ahead and doing that? And there are a series of different challenges we see today. And so the first is pre-processing, right? This means of all your data, how can you get it in a shape where the model is really ready to handle it? And so this today is done based on the variety of different data types. So for text, we have techniques like segmentation, tokenization, missing value strategy, and so on. And then for tabular, we have things like normalization, lowercasing, and others. And so today, this is kind of done at an individual modality level, right? Where for each modality, you'd have to kind of pre-process it separately and then figure out a way to actually combine those models into a unified framework. And so today, what we've seen is most companies that are doing multimodal machine learning tend to use multiple frameworks that really result in sort of clunky pipelines where you maybe have to ensemble, where you take the output of one model and you feed it as input to another. All in all, this requires a lot of low-level code, usually in PyTorch or TensorFlow. And then you're going to have to do hyperparameter tuning, right, to make sure that you're actually getting the right performance that you're looking for. And then finally is all the infrastructure, right? Because as you're building and training these models and you have things like unstructured data, chances are you want to use like GPUs to kind of make the best use of and train these models effectively. And so this is the model training part is really where Predibase comes in, and where we see, especially when you have both structured and unstructured data, there's no sort of standardized way for anybody without a lot of machine learning expertise to go ahead and build those models. Now, if we thought model training was hard, deployment's usually even harder, because now we have to take this development code, transform it into production code. We then have to maintain the evolving libraries, because once this model is out in the wild, who's to say how users will interact with it and the types of predictions that we'll start to see, right? And ultimately, since these pipelines are really brittle, this allows for, or this basically makes it so that it's not really standardized, and that there's a high risk of breakage in production. And so that's the last thing we want, right? Is for these models to go ahead and break while they're deployed. All this being said, this ends up taking around 6 months to a year to finally get from your pre-processing, training your model and distributed infrastructure and then finally deploying it, it takes around 6 months to a year, and really is just not an effective way to develop machine learning workflows. Ultimately, what we've seen also is that your first model is very rarely your last, right? And so let's say you want to iterate. Let's say maybe you have now a new feature of images where people are adding images to the reviews, and you want to kind of use that as input to the model. Well, now what would you have to do? You'd have to go ahead and retrain a model from scratch. Now using image data, figure out what are the best ways to go ahead and pre-process that. Again, figure out if you can train those models in an effective way, and then finally deploy that brittle pipeline of maybe an ensemble of models or something else, where it's not really clear how can I go ahead and do this in a seamless way without taking, let's say, another year or two just to go ahead and get this model into production, right? And so what this sort of the key takeaway here for me is that multimodal models in production are really hard to do and take over years to really get right. And so let's kind of see how we can do that live with Predibase. Cool. So now let me go ahead and hop over to the demo and kind of show you how we can do this in Predibase. Cool. So hopefully you guys can all see my screen. So what you're seeing here is just a quick preview of the Predibase platform. We can see that there are a few user journeys here, from connecting data, training models, and then going ahead and querying and operationalizing those models. You may notice that there's actually this idea of engines, which I'll get to in just a minute. But I do also want to highlight that today we'll be covering the graphical user interface, as well as Pico, which is a predictive query language. But everything we do today is also available via Python SDK. And so if you're more familiar with Python, if that's kind of how you're used to training models, everything we do today, you can go ahead and do it via the Python SDK as well. Cool. So let me just spend a minute talking about engines, because I think this is a really key value prop of our platform. And just as a quick definition, an engine is basically an abstraction on top of compute, right? And so the high-level problem we've seen is that as organizations develop machine learning systems in-house, the key pain point is that they have to set up and maintain all this infrastructure on their own. And infrastructure tends to be one of those hidden costs that turns out to be extremely difficult as well as time-consuming for an organization. And so to that end, this idea of an engine is basically a neat abstraction layer that can handle distributed training at scale and allows you to sort of fan out computation to a variety of CPU, GPU, or even hybrid engines. And so for those of you that are also familiar with modern data tools, this is sort of analogous to Snowflake's concept of a virtual warehouse as well. Awesome. So let's go ahead and get started with this use case. And the first thing we want to do is go ahead and connect data to the Predibase platform. And so we can do that just with one click. And we can see that there's a variety of data sources available for us, from our structured data like Snowflake, Redshift, BigQuery, to maybe our more unstructured data. Maybe that lives in Amazon S3 or GCS. In this case, I've actually gone ahead and uploaded our data set directly, so we can go ahead and start to look at it immediately. And so I think now we can kind of look at and start to see some of the use cases of our predictive query language. And so here we have our query editor, where we can see that what we've done is we've gone ahead and written a simple select stars statement similar to what you do in SQL, where I can go ahead and select 20 rows from this e-commerce review prediction data set. And so here we can see in line, what does this data set actually look like? We have the column for our clothing ID. We have the age of the reviewer. We also have some other structured data, like let's say the division name and department name. But what's really interesting is we actually have unstructured data here as well, right? So we have the title and the review text of the individual reviews, right? And so the column we're going to be trying to predict today is actually this rating column, right? And so we're going to see, can we use all these features, so the structured and unstructured data, to go ahead and predict this rating right here. And so one thing, just to kind of give you a sense of what these reviews look like, is let's take a look at this example. We see that in this case, there's typos, there's not really complete sentences, a lot of kind of messy data, right? And so this is typically how data is, right? Where you have very unstructured data where this is sort of how people leave reviews. And so we'll kind of see how Predibase is designed to kind of solve use cases like these and make use of all this unstructured data. And so there's two things to kind of call out here in terms of PQL. One is that, as you may have noticed, it's really convenient, right? To just go ahead and say, hey, let me like take a look at my data set and see what is the sort of structure of the data, what are sort of the values that it takes on. Let me understand at a little bit at a deeper level, what does that data look like? But then also is flexibility. And so while in this case, we're using it more for exploratory sort of data analysis, we can also use PQL for other things like predictions, which we'll see later on in the demo. But with that, let's go ahead and see how we can go ahead and actually train a model in Predibase. And so we have this idea of a model repository. So let's go ahead and say, I want to go ahead and create a model repository. In this case, I can call it e-commerce review predictions. And the description is going to be maybe something like, I don't know, predict rating based on customer reviews. You may be wondering, hey, why is this called a model repository? Why is it not just a model? And the reason for that is that a model repository really allows you to kind of store, collect, and version all of your model iterations for a given use case. And so in this case, we've gone ahead and created that model repository. And now we can go ahead and train that first model. And so let's see how simple this really is. In this case, we see that we have the ability to go ahead and kick off a series of baselines. And so these would be kind of recommended models from Predibase, customized to your data set, and based on some internal benchmarking that we've done to recommend sort of the best model architecture for your given data set. In this case, I'm just going to go ahead and train a single model so we can get it up and running pretty quickly. We'll notice here is this idea, again, of engines, right? And so this is kind of what's handling all the infrastructure under the hood. In this case, it's as easy as a dropdown. I'll go ahead and select my training engine. And then all I need to do is go ahead and select that e-commerce review data set. And then we can go ahead and see that as it's pulling up, we should be ready to go to train this model. And so we see that we've gone ahead and selected our e-commerce review prediction data set. We also see that actually those features that we were just taking a look at in PQL have been sort of automatically inferred here in terms of the column names, as well as even the individual data types. And so in this case, let's say I actually want to choose rating as a numerical feature, right? Because I'm really interested to see how close can the model get to predicting the exact numerical rating. Cool. And then we can go ahead and see we have our binary number and category features, and we do want to predict rating. And so for us to predict rating, all we have to do is specify our target right here. And we'll see that immediately this next button is sort of highlighted. So in this case, I think we're ready to proceed. One thing I'll sort of highlight here is we do have a variety of different model types supported out of the box. So in this case, I'll just go ahead and train a neural network, but we also will take a look at how Predibase supports gradient boosted trees as well. And so both of these model types are supported within the platform. It's totally up to you to choose what models you'd like to train. We do see that gradient boosted trees tend to work better for small and tabular type data sets, but neural networks are better for larger data sets, especially when you have unstructured data. So let me go ahead and hit next, and we can see that immediately I can go ahead and hit train to go ahead and kick off that model version. Cool. And so now while this model is training, we'll start to see the learning curve show up here, and we can kind of evaluate these in real time. But given that this may take like 5 to 10 minutes, let's go ahead and actually take a look at a fully fledged model repo with some already trained models. So I can go back here, and let's go ahead and look at these already trained models that I had trained before. And so a few things to sort of note here. We can see that we do have a variety of different models with their descriptions. So we have some baselines, we have maybe an experiment, and we have some iterations that we'll take a look at. We can also see some helpful metadata, right? So we can see the duration of how long it took, as well as the status of the model itself. And so in this case, let's go ahead and look at that GBM model actually, and let's see what the tree model looks like. And so here you can see a variety of different metrics right off the bat. And so you can see the learning curves for the loss and how this model was sort of learning over time, right? And you can see that the data set was automatically split into train, validation, and test sort of splits, and then how those were used to go ahead and train the model. We can also see a variety of different metrics that are relevant for my use case. And so in this case, since it is a regression task, we can see metrics like your MAE, your mean squared error, as well as your R2, which is sort of the metric we're going to be taking a look at today. And so we can see that while these loss curves look okay, there are kind of a variety of other charts available for us to look at. And so we do offer confusion matrices, ROC curves, and others. But given that this is a regression task, we won't dive too closely into those today. And so this is kind of what I want to spend a lot of time today looking into, which is a feature importance plots, right? And so we can see that in this gradient boosted tree model, the recommended feature, right? And so this is basically describing whether a user recommended this feature. This is sort of one of the most impactful features for that the model used to make predictions, right? And then again, just to give an overview, these feature importances are created through a technique we call SHAP, which allows us to basically understand the relative importance and weighting that the model is using internally to go ahead and make predictions. And if you think about this, this makes sense, right? Because if someone recommends a model, that's likely pretty correlated with the numerical rating of how well they rated that particular feature. And so let's actually go ahead and look at a trained model, which is the same one we just trained, right? Which is that default neural network model. In this case, we again see our learning curves and our loss, and we also see these helpful metrics on the left. One thing that's really helpful is that to call out is that every model in Predibase is actually backed by a configuration file. And so this is actually what's coming directly from Ludwig, right? Where if you ever want to, you can go ahead and take this config file, use it in our open source Ludwig, and get the same exact model that you would write within Predibase, right? But what you can see here is that we are using the variety of different features, including your binary, your numerical, and your categorical features for those division and department names. But what you may notice actually is that we don't have any unstructured data here, right? All of these are actually just numerical, binary, and category features. And so I think what we would want to do actually is let's go ahead and take a look at a model that I have trained with that unstructured data, right? And so this is sort of gets to the benefit of Predibase, right? Where, again, in this case, if I now look at this configuration, we can see that we have actually added our text and review text features. And we can see that the learning curves here are kind of decreasing over time with the loss, right? If we were to look at the R2, we can see that it went up from around like 0.4 to around 0.63 now that we've used the text features. And actually, one sort of simple way to look at this is actually, let's go look at the feature importance plots of this neural network with text features. And so now actually that recommended feature is no longer the most important feature that we're using for predictions. It actually is the review text and title, right? And so this sort of emphasizes the importance of unstructured data, right? Because as soon as we've added these unstructured features, in this case, the review text and the title, we can see immediately that this model was using these pretty heavily to go ahead and predict that rating feature, right? And so this is sort of case in point, right, as to the importance of using both your structured and unstructured data when you have it available, right? And so that's kind of what Predibase makes really easy to do. I do want to take this opportunity to go ahead and show you some of the benefits that come along with having a model backed by a configuration. And so, for example, we've seen that we have some baselines, we have a few iterations. Let's go ahead and look at how we can compare this over time. So given that a model is just a configuration file, what we can actually do is we can say, hey, let me compare my initial baseline and let me compare it to that neural network with text features, right? And so what you can see here is actually this sort of Git style diffing where we can see that, okay, in this iteration, I've actually added these two features as well as some pre-processing and some other sort of parameters. But what this allows you to do is now say, okay, I can very quickly understand between these two model versions what was really different and how has that sort of impacted the ultimate performance of the model. And so let's say I see that, okay, it seems like this iteration 1, model 16, has gone ahead and added these unstructured features. What does that really mean, right? What I can do is I can actually go ahead and compare all of these directly in this unified comparison view, right? Where I can see those same charts as before. So both our configurations, as well as learning curves, but even our feature importance plots, right? And so let's say I do want to compare model 16 with model 1. What I can do is I can go ahead and see that, okay, I can have both of these compared side by side, right? And I can really see the loss curves here for me to kind of visualize. And I can also do this for any of the plots that are available, right? And so let's say I have my first baseline and I have my neural network with text features. Now we have a side-by-side view, right, of what were those most important features and how are they sort of changing over time. And so we can see that the review text and title sort of like severely outweigh any of the other features that were used, right? And so especially when we look at the performance of the model, which we can kind of look at here, we can see that the performance of, let's say, our R2 on the test set was much higher, 0.63 compared to our 0.61 default baseline here. Cool. And so now that we've seen this, let's actually take a look at, and let me show you how this model iteration journey actually works, right? And so let's say I have this iteration number 1, where I've added my, unstructured text features. What if I want to go ahead and improve this even further, right? Like I like 0.63, but maybe I want to try something even more fancy. What I can do is I can go ahead and very quickly just say, hey, let me go ahead and create a new model from this version. And what this will do is it'll load up that same model builder screen we saw earlier, right? Where we've gone ahead and just loaded all the defaults that we used from this previous model. And now we can go ahead and see if there's anything we want to tweak, right? And so in particular, what I want to show you is actually this idea of this glass box approach, right? And so what you're seeing here is actually the ECD architecture, right? That encoder, combiner, decoder architecture that we were talking about earlier, right? Where we have your input features on the left. We can see how they're pre-processed as data types, how they're encoded into tensors, how they're combined into a unified representation, and then ultimately how they're decoded into predictions out on the other side, right? And so let's take a specific example. Let's say I want to look at review text and how it was pre-processed. Here I can see that I can specify any one of a variety of different tokenizers that I'd want to use. I can specify things like the max sequence length. I can obviously do things like missing value strategy, right? So let's say I had missing values. How would I go ahead and impute those values so that the model has some data to train on? I can then also change the encoder. So let's say in this case, I'm using a parallel CNN, but I also have access just from a dropdown to a variety of cutting edge state-of-the-art machine learning models. And so, for example, I have access to transformers. I have access to things like BERT or GPT-2 or T5 or others, right? And so once I go ahead and select, let's say, BERT, I can go ahead and pretty easily decide whether to go ahead and train this model as a pre-trained model and whether I want to go ahead and fine-tune it on this data set, right? And so all of this is sort of available for you. And then, of course, there's some more advanced parameters as well. So maybe you want to specify things like your classifier dropout or your initializer range. These are sort of these are possible as well. And I think this is sort of one of the key value props of Predibase, right? Which is that, hey, let's say I don't really know what these parameters are. We come out of the box and just suggest defaults for you, right? And so these are best practices based on what we've seen work. But if you're an expert user and you want to kind of modify these and play with them and see how it impacts performance, you have that flexibility and to go around and kind of modify them and see how it works, right? And so with that, we've kind of seen how we can iterate. And so we have this sort of glass box view where we can just very clearly and visually understand how is that data coming in and how are we forming sort of this compositional model architecture to kind of get those rating predictions on the other side. We also have a very similar view through parameters. So let's say I want to go ahead and change some training parameters. I can go ahead and change things like learning rate or batch size. And here we can see that, hey, maybe you're not familiar with what is batch size. We have very handy descriptions here to kind of help you understand that, like, okay, here's what batch size is, here's where I may want to change it. And again, if you're not really familiar, the default is auto. And so we'll go ahead and just auto determine the batch size for you based on your data set and the model you're trying to train. Cool. And so you can imagine that by going ahead and, let's say, using a heavyweight encoder, I can actually go ahead and get this final model version, right? Where in this case, what I've done is we've actually added defaults for the text encoder. And so in this case, we wanted to use a very heavyweight encoder called BERT, which is coming directly from Hugging Face, and then setting trainable to true, meaning that we want to fine tune on our given e-commerce review data set. We can also see that our test rating R2 was actually the highest across all of our iterations, in this case around 0.66. And then just for, just out of curiosity, let's go ahead and see that, yeah, even in this final model, the title and the review text significantly outweighed any of the other features that were used for prediction. Cool. And so now we've seen kind of that iteration journey, right? Where within this single model repository, I've gone ahead and trained a few baselines. I've experimented with tunings of different parameters. I've then added unstructured data, and then even used a heavyweight encoder like BERT to go ahead and fine tune that on my data set, right? I can easily go ahead and compare those across all those model versions. And I can even do things like diffing those models to kind of see what exactly the difference is in a very succinct format. So now that I have this model, let's say this is my final model and I'm really happy with this and I want to deploy it. I can go ahead and deploy it with one click. So I can go ahead and hit deploy, and all I have to do is kind of give it a deployment name. Let's say e-commerce reviews deployment. And what we'll do is we'll automatically suggest a serving engine to kind of host this infrastructure. And what this will return is basically a REST endpoint that you can then query in your downstream applications. If you do have, let's say, your own serving infrastructure, you can go ahead and export this into a variety of different formats. So you can choose Ludwig, which is obviously that configuration we were looking at earlier, or even others like TorchScript, Neurapod, and even Triton. These both are mostly useful for real-time inference, but let's say I wanted to go and actually do batch inference. This is where we can go back to PQL and see how PQL can be used to kind of run batch inference. And so let me go ahead and actually pull this query up from history, just to kind of show you the results. And so what we can see is that actually what we're able to do is, in just one line, we're able to transform that initial select star query that we were looking at earlier, where to explore the data, into a predictive query, where now we want to predict the rating, right? And what we see is actually that we have the rating here, as well as the rating predictions coming directly from the model, right? And so in a pretty similar to SQL and familiar interface, we're able to go ahead and explore inference and explore these predictions and understand that, okay, like for this given row, let's understand sort of why the model was predicting the way it was. And in this case, we can see that actually the rating prediction was pretty close to the rating of the ground truth, right? And so what's really useful about this is that in this case, I'm just kind of predicting rating across 20 examples. But let's imagine you want to use this for a real use case. What I can then do is go ahead and remove this limit 20. This will go ahead and predict the rating across the entire data set. I can then go ahead and schedule that query, right? And so maybe I want to have this run on an interval, let's say every day or even every week, right? And what I can do is then go ahead and run those predictions on a weekly cadence, and then go ahead and write that out into some external data source, right? Maybe I want to put it into BigQuery, or maybe I have it in Snowflake or something else. I can very easily go ahead and kind of take these predictions and the results here and write them back out into an external data sink. Cool. I do want to kind of just briefly mention some of the other features available with PQL. So earlier I mentioned that it's very flexible. And so just to give you an example of things you can do, you can do things like, let's say, with confidence. So if I wanted to get the specific confidence of a given prediction, I can go ahead and do that just by adding confidence. one that we see customers really like is the idea of explanation, right? And so we saw those explanation feature importance plots on the models page, but I can actually go ahead and run those directly here as well. And in line, we can see those predictions at a global level, as well as at a row level. So if I'm really confused as to like, hey, why did this particular data point have this prediction, I can kind of see what are those most impactful features there as well. And one really interesting query I want to show you is this idea of a hypothetical query. And so let's say I'm just curious to understand the model. What I can do is I can actually run inference on a single data point. And so I can do that by basically saying, hey, I want to predict the rating given these specific features. And so let's say I have the age of 39. And in this case, I just like came up with a pretty disappointing review where the user was saying like, hey, this is a huge disappointment. I had really high expectations, but the quality was cheap. I'll have to return this. And so clearly this is not a great review, and we shouldn't expect a very high rating, right? What we can see is actually, given this totally custom inference, and again, I can change these to whatever I want, I'm able to kind of query the model in real time. And I can see that, okay, yeah, as expected, this rating was pretty low, a rating of under 2. So cool. With that, that's sort of all I had today. Hopefully, this was interesting to kind of see how we can go ahead and from connecting your data to iteratively training models on multimodal data sets, and then ultimately querying them and deploying them into production. So I'd love to hear any questions or comments that people have.
Great, Abhay. Lots of questions in the chat, so I'll just kind of go through them. Excuse me, we've answered some of them, but I'm happy to sort of ask them live for you to give your perspective. So someone asked, can you further fine-tune models with Ludwig on domain-specific data sets?
Can you further fine-tune Ludwig on domain-specific data sets? Yeah, so actually what I was showing you earlier is that we were able to fine-tune this this model, use fine-tune BERT actually on this specific data set. And so you can do this very easily for any other data set you'd want, right? And so depending on the data set, you can go ahead and specify that model architecture, select BERT, and then go ahead and fine-tune for any given use case that you're interested in.
And as Connor mentioned in the chat, who's one of our engineers here at Predibase, that we do support a wide variety of Hugging Face models, which can usually be used and tuned. Let me go through the questions here. Hold on, going through. Someone asked about explainability, like Shapely-like metrics for multimodal models. It'd be helpful to see. We're not going to cover how we support that, but maybe we could speak to how we support that in Conrad response to as well. I could mention.
Cool. On feature affordances?
Model explainability.
Yeah.
For multimodal models and data combinations, and how we sort of handle that and showcase that platform.
Yeah, it makes sense. I think, yeah, one of the key ways we do it is through model explainability and through feature importance. And so we offer a variety of different techniques out of the box, including both Shapley as well as integrated gradients. And so this allows you to basically understand what are those key drivers for a given prediction pretty intuitively.
Yeah, and Connor also added that we support token level explanations for text and working on additional support for image and audio explanations in the form of heat maps and the like. So additional features coming. Going through the questions here. Someone asked about Ludwig support for time series data. I wonder if you have perspective on that.
Yeah, so Ludwig does have support for a variety of different modalities, so including text, tabular, as well as actually time series. And so that's something that's available in our Ludwig docs. And so we have an example there, which I can post in the chat later, just about how you can go ahead and kind of play around with time series within Ludwig.
Awesome. And I did post there is a tutorial specifically around a use case. I think it's weather data that I posted in there for folks. They can go and get into it. Someone asked, how do you figure out the cost of training? And I can just answer this, on the Predibase platform, and you can feel free to add as well. We show you how much compute you've used in the platform, and are adding additional functionality such that you can see the price of that compute and also put caps on that as well. And then there's a question about, in order to merge two data sets together, like structured and unstructured data, do you use a common key? And is that what Piqua helped you do, or how do you go about doing that?
Yeah, actually, so in this case, I actually had the data set sort of combined initially, but we have this idea in the platform called external connections, where you can go ahead and actually, let's say, take a data set and then connect that out to wherever your unstructured data is. So maybe that lives in S3, maybe it lives in GCS. You can go ahead and pull in individual columns for that unstructured data, just using those credentials for that connection.
And someone just asked to reiterate like how we define multimodal models, if you could just give your quick definition of that.
Sure, yeah. So multimodal models are essentially any model that uses multiple modalities. In this case, we were looking at the modalities of structured and unstructured data. And so structured meaning things like category, number, binary, and unstructured being things like text, image, audio, and looking at how we can develop a unified model to take in all of those inputs while predicting a single output.
And someone was asking about sort of data management and at the lake, and there's a response in the chat, but I'll just reiterate that we do work with a number of large enterprises, like in healthcare and financial services, that have sensitive data, and so we're very comfortable with that. Maybe one more question on the building on the multimodal sort of machine learning models. Abe, you talked to a lot of customers and companies or building these models. What are some of the most common use cases that you see organizations tackling?
Yeah, I think we see a variety of different use cases. The key really being here is that you have some labeled data set that you then want to predict a certain column on. And so we see examples across, like, let's say, customer service. We see like fraud detection, churn prediction, lots of different use cases, of course, including e-commerce reviews. But really, we just want to make sure that when you have that data, both structured and unstructured, you're able to use it. And so one particular example that I like is in healthcare. We have a healthcare company who's doing a lot of machine learning models around using text data, right? So from the reports of their doctors, understanding what patients are at risk for certain diseases. And so that's a perfect example of how we can use both the structured and unstructured data to go ahead and train models.
Awesome. So we're at the top of the hour. I want to thank everyone for joining today. And Abe, I want to thank you. Great demo and discussion. There's a few questions we didn't get to, so we'll make sure to follow up with you individually. And I want to remind folks that two things. One, make sure to join the Ludwig community and download the open source package, and you can start playing with it today. It's www.ludwig.ai. You can also head over to predibase.com and go to our blog. I put this in chat, but we actually have the use case that Abe covered. We have a tutorial for it with sample notebooks, sample data and code, so you can build it end-to-end, your ML pipeline. And of course, if folks are interested in trying out Predibase, you can go to our website and request a personalized demo, and we'll be happy to showcase more and get you started building with a declarative approach. So thanks again, and we'll be talking to you soon. Take care.